So three-phase balanced loads, power. So if it's balanced, what you'll remember is, if a load is balanced, that means it's the same thing in each of the three, the red, the yellow, the blue. Your notes should cover all of this. These slides came from your notes.
This also be closed book, or is this open book?
I think I'll just do this as being an open book.
No, I forget to be honest.
So, when you're working out the power in each phase, you do the voltage across each phase, the current through each phase, times the cos of the phase angle in that branch. So your total power will be 3 times the phase power. You can also work out your total power using this formula here, root 3 VLIL cos of the angle. I think that's the more difficult way, so my preference is to do it that way. And it also works for unbalanced as well. And you don't have to worry so much about phase angles, you can more kind of think about magnitude, so it's more straightforward. So that's what we're going to do. In the same way that you can do that for true power, P, you can do that for S, apparent power. You can do V phase, I phase, and that your total apparent power is 3 times that, because there's 3 of these phases. And then in the same way as your power triangle works for every other AC circuit, it works for your 3-phase circuit as well. So once you've got P and you've got S, you can work out Q using Pythagoras, can't you?
Yeah.
So that would be the style of what you're doing. And this is covered on your notes. In a slightly different way on your way up to page 4. Then you'll see on page 4 we have this example. So it's 3 identical loads of impedance, 10 at an angle of 30, are connected in a star across a 400 volt 3-phase supply. Determine the total apparent, active and reactive powers for the circuit. Now, apparent power is S, active power P, the same as power dissipated or true power, and reactive power is Q. And it's a star. So because it's a star, what does that mean for the voltage?
I was going to say 3 phase, but it was that, so.
So remember, that's what a star looks like. The voltage they give to you is the line voltage always in the question. So if they're saying to you that voltage is 400 volts, you're going to have to divide that by root 3 to get your phase voltage. If they'd said to you it was a delta, these two voltages are the same and you would do nothing. So that's our kind of first thing to consider. It's a star. So in a star, your V line, given in the question, has been 400 volts. And your V phase, will that be that V line divided by root 3. So 400 divided by root 3, I'll think because I'm so predictable, that'll be 230.9. Yeah, that's one of mine. Yeah. So that's the voltage I'm going to use throughout. That's my phase voltage. Now, you'll notice just now I'm only using magnitudes. I'm not including any phase angles. I don't need any phase angles because I'm using this method. So my V phase, and then I'm going to get my I phase. So because I'm using this method, I can just do I equals V over Z. And I'm only going to use the magnitudes. So my V phase, my 230.9, I'm going to divide that by the magnitude of my Z, which is just the 10. So as long as you're in polar form, you just take the magnitude from there down to there. Yeah? So if you're in rectangular form, go into polar form first and get that magnitude and take it down. Just leave the angle where it is. I'm going to actually split my page. With a makeshift ruler. So now from this, I can get the power in each phase. And it's P, so this is active power, true power, power dissipated, however you want to describe it. Again, for your V phase and your I phase, you just take your magnitudes. And your angle will come from that angle in the impedance, that 30 degrees. And true power, active power, power dissipated, all those real powers, they are measured in watts. And it's a three-phase circuit, so once you've got the phase power, if you want the three phases, then all you have to do is take that phase power and multiply it by 3 for each of those three phases. And I'm going to change into K here because it's such a big number. So 13,000, so 13K.851. And that's my phase power and my total power. The next one I'm going to do is S. Same idea, S phase. B phase, I phase. And S is measured in VA, volts amps. Remember, S, apparent power, is really only used for ratings and things like that, it just gives you an indicator. And your S total, in the same way as your P total, is just your S phase times 3. And again, I'm going to change it into Ks. That's me done my P, my S. Use the other half of my page. I can do my Q the same way. Q phase. B phase, I phase, sine of the angle. Same V. Same I. Sine this time, and the same angle. Remember, Q is measured in volts, amps, reactive. A measure of the energy that's exchanged between inductive and reactive elements. And then your Q total. Q phase times 3. 7.997 kVAR. And just to make sure that what I've done is correct, I'm going to check it. So I'm going to check it using Pythagoras, because I know that P squared plus Q squared should be equal to S squared from your wee power triangle, where P goes across to the right, Q is there, S is there, and that would be your 30 degrees in this instance for your angle. That's your right angle there. So this would be true for P phase and for P total. So I'll use my totals to check. So P total. So I'm going to do 13.851 squared plus 7.997 squared equals 'm going to take the square root of that. $15.994, which ties up with my 15.994 that I got there. There it is, so that's right.
Yep.
So that is the same as that, so it's checked and it's fine. Really the only difficult thing in it, or the only thing to kind of bear in mind, is when you check if it's a star or a delta. When it's a star, you divide that by root 3. If it says delta, don't divide that by root 3. Your impedance has to be in polar form, so that you can use the magnitude when you go to work out your I, and use your angle when you go to work out your true power and your reactive power. If it's in rectangular form, put it into polar form first. And the question for you to do is on the next page, example 2, page 7. And hopefully that's one that I've got the answers to in my thingamabobber. I'll close that.